Text files are a fundamental data storage and communication medium in computer science. These files contain human-readable text in the form of characters and are widely used for various purposes, ranging from data storage and configuration to data interchange. In this video, we will dwell into the purpose of text files and discuss some common text file formats, along with an analysis of their pros and cons. Text files serve several critical purposes in computer science and programming. Text files are commonly used to store data that can be easily read and edited by both human and software. Configuration files, logs, and databases are often represented in text file format. Text files are an essential means of exchanging data between different systems and applications. They are platform independent and human readable, making them an excellent choice for data sharing. Programming languages like Python and Java use text files to store source code. These files contain the instructions that a computer needs to execute a program. There are several text file formats in use today. Some of the most common ones include plain text. Plain text is the simplest text file format containing unformatted text without any special structure. Comma-separated values, or CSV files, are used to represent tabular data, with values separated by comma. They are widely employed in data analysis and spreadsheet applications. JavaScript Object Notation, or JSON files, store data in a structured, easy-to-read format. They are commonly used for configuration files and web data exchanges. Extensible Markup Language, or XML, is used for representing structured data. It's commonly found in web services, configuration file, and document storage. Text files offer several advantages. They are human readable, making them particularly valuable for configuration files and debugging. This readability simplifies manual editing and troubleshooting. Text files also provide platform independence, as they can be effortlessly shared and utilized across diverse platforms and systems, enhancing their portability. Moreover, text files enjoy widespread support. Nearly all programming languages and applications can work with them, ensuring compatibility. Conversely, text files exhibit certain drawbacks. They lack the structure, organization, and indexing capability found in formats like databases, which can complicate the handling of complex data structure. Additionally, text files are not optimized for efficiently storing large datasets. Retrieving data from extensive text files can be slow, making them inefficient for use in this case. A text file encoding, also known as character encoding, is a system used in computing to represent text characters in a digital format. It defines how the binary data stored in a computer's memory is interpreted and displayed as human-readable text on the screen or in a file. Text file encoding is essential because different writing systems and character sets exist, each with its own way of representing characters. Encoding ensures that text is displayed correctly and consistently. The most common text file encoding include UTF-8, which is the most widely used encoding for text file. It supports a wide range of characters from various languages and is the default encoding for many programming languages, web content, and data interchange formats. It's a variable length encoding, meaning that it uses 1 to 4 bytes to represent characters. A simple format, ASCII for American Standard Code for Information Interchange, is a simple encoding that covers the basics English alphabet, numbers, and some common symbols. It uses only 1 byte, or 8 bits, per character and is widely supported. The ISO 8859-1, also known as Latin 1, is suitable for Western European languages. It covers characters like accented letters and additional symbols. However, it doesn't support characters from other languages. The Windows-1252 is an extension of ASCII and is commonly used on Windows systems. It includes characters from Western European languages and some additional symbols. The choice of encoding depends on various factors, including the language and character set you need to support, the platform your application runs on, and a compatibility requirement. UTF-8 is often the preferred choice for new application and cross-platform compatibility, as it covers a wide range of characters and is supported by many programming languages and systems. However, it's essential to choose the encoding that best suits your specific use case. Python provides robust support for working with text files. We will explore best practice for handling text files in Python, including examples with and without the with statement. When working with text files in Python, it's essential to follow best practices. The with statement ensures proper handling of file resources. It automatically opens and closes the file, reducing the risk of resource leaks. Here's an example of using with to read a text file. The first line opens the file named sample.txt in read mode. The with statement is used to ensure that the file is properly closed after it finishes executing. This is a recommended way to work with files as it automatically takes care of closing the file, even if an error occurs within the block. The second line of code initiates a loop that iterates through the lines of the opened file. In each iteration, the variable data will contain the content of the current line in the file. Finally, the third line of code prints the content of the current line to the standard output, usually the console. Be careful, when you call the open function without specifying an encoding, it uses the default encoding of the system where your Python script is running. This default encoding is typically determined by the system local setting. For many systems, especially those using common English-based locals, the default encoding is often set to UTF-8. However, it's important to note that this can vary depending on the operating system and local configuration. In some systems, the default encoding might be different, such as CP1252 on some Windows installation, or ISO 8859-1 on certain Linux distributions. To ensure consistency and avoid encoding-related issues, it's a good practice to specify the encoding explicitly when using the open function, as shown in this example. By specifying the encoding, you make your code more robust and portable, as it won't rely on the system default encoding, which can lead to unexpected behavior when the code is executed on a different system. While using the with statement is recommended for resource management, it's worth noting that you can handle text file without it, though it required manual opening and closing of the file. In this case, we need to open the file within a try finally statement to ensure the file is closed even if an error occurred during the process. We make sure to close the file within the finally close. However, the with statement is preferred because it simplifies the code and mitigates the risk of forgetting to close the file. The Python language also supports writing to text file using the open function with the W parameter for write option. In this example, we want to write the text. This is a sample text that will be written to a file, into a file named output.txt. Similarly to the code used to read a file, we use a with statement. The expression file.write, data to write, writes the text into a buffer, and then the buffer is flushed to the file itself when exiting the within block. What do the term buffer and flushing mean? When writing data to a file or an output stream, it is typically initially placed in a memory buffer for efficiency purposes. Flushing the output buffer involves the immediate transfer of the data from this buffer to the intended file, ensuring that it is not left pending in the buffer. This is done automatically when you are closing the file in Python. You can explicitly trigger this process using the function like file.flush and open/close parentheses. This ensures that the data is promptly returned to the target destination, preventing any delays or data loss due to data remaining in the buffer. There is an important point to keep in mind when writing to a file with Python. When using the function open with the option W, if the file output.txt does not exist, it is created by the function call. However, if the file already exists, the content of the file will be erased. Thankfully, Python provides a way to add more data at the end of a file without erasing its previous content. In this case, you need to use the open function with the option A for append. In this example, line 1, line 2, and line 3 is added at the end of the file output.txt. In conclusion, understanding how to handle text file is a fundamental skill for any programmer or data enthusiast. Text files serve as the backbone for various applications, from storing configuration data to exchanging information between systems. In this video, we have explored the purpose and common format of text file and discussed the pros and cons of using them. We also delved into the world of text file handling in Python, emphasizing the importance of the with statement for efficient resource management. By following best practices, such as specifying the encoding and using appropriate modes, Python developers can effectively read from and write to text file, ensuring data integrity and efficient file operation. Whether you are working with simple plain text file or more complex data in format like CSV or JSON, mastering text file handling in Python is a foundational skill that empowers you to manage, manipulate, and exchange data with ease. It is a crucial step on the path to becoming a proficient programmer and data handler. Thank you for watching, and see you in the next video.